Hi, this is Alexi Karve. Today I will be demonstrating the MicroShift running on a Raspberry Pi 4 with Oracle Linux 9. I'll be executing some of the samples for Kata containers and virtual machines. So let's get started. So you can see that I am currently running Oracle Linux on the Raspberry Pi 4. And if I run a watch command for MicroShift with the OC, you should be able to see that I have the KubeVirt installed, I have the console deployment installed, and the CDI installed. So I should be able to run samples with the containerized data importer and virtual machines. And I've also installed Kata. So all of these instructions that I followed to install these are based on this particular blog. And what I'm going to do is I'm going to go to the Kata samples and run this particular sample. So first of all, I will go to this folder and apply the Kata runtime class. Okay. Then next thing I want to do is run the InfluxDB sample. So I will go into this folder because I have already downloaded this from GitHub. And this thing adds the runtime class of Kata to these three files. I have already added them. I will look at one of the files. And you can see this runtime class name of Kata has been added over here. So I'm going to run this container within Kata. The node name, which is there in my case, is rpi.example.com. So let's just check, that the node name is indeed set correctly. You can see the KubeVirt provision on node is set to rpi.example.com. So this is good. So when we create the persistent volumes, the persistent volume will get created using the KubeVirt host path provisioner on the single MicroShift node that we have on the Raspberry Pi 4. Now let's run this. So this will go and create the multiple pods that are required. So while it's creating that, we can watch the pods as they are created. You can see the InfluxDB is currently being created. What we are going to do is we're going to see that these are indeed created using the Kata container runtime class. The measure deployment is being created. This measure deployment doesn't run in Kata. If we run this command, it will show the runtime class for the pods that are being created. See that the measure has now been deployed, and now the Telegraf is currently deploying. Now the Grafana service is also deployed, and we should be able to connect to this particular route, Grafana service. So let's click on this. and log in using admin and admin as the password. And it asks us to change the password. We'll skip that. And you can see a couple of dashboards that are already pre-created. So if I go to the Balena Sense dashboard, you can see the current humidity and the temperature and the pressure. And it will be able to collect this information. Also, if you want to look at the analysis server, then it actually shows us the current details from MicroShift, how much memory is being used, the total number of processes, threads, and all those details, the disk percentage used, and so on. So this was the first demo on using Kata containers. And we can, of course, check now that everything is started. These three containers, the Grafana, the InfluxDB, and the Telegraf, were started using Kata. And you can see that these were started using QEMU KVM. So you can see those processes that were started using QEMU KVM. Now let's delete this sample. And we can check that we were currently so you can see the image and the init RD. So we are currently using the init RD instead of this. So we'll switch now. We'll also disable the NVDIM. Default is false. We'll have to disable it. So it is disabled now. And we'll restart Cryo and apply the Kata Alpine. We are just checking that the InfluxDB and everything has been deleted. Good. So all pods have gone. InfluxDB has been deleted. Now we'll create the pods using the second mechanism. So the Kata Alpine pod will get created now. So you can see the Kata Alpine pod is currently running. And if we do now, you can see that it is using the kernel. So let's delete this particular pod now. And now we'll try to run some examples for virtual machines. So let's try to run the one with CentOS. So first I'm going to pull this image and run it using the Docker container that I had built containing this CentOS image. So it has already been pulled. We can go and change the authorized keys over here or the password. And once we do that, then we can apply this YAML file. We can see that this VM is stopped. So let's start this VM. It was scheduled to start. So it is currently starting. And now it is running. So we should be able to connect to this VM CentOS 9 now. And you can see that it is being booted. So while it is booting, what we can do is we can start the CDI importer and create another VM. So we'll do that while this is being booted up. So let's look at those instructions in the blog. So I have already replaced the binary with a fix so that we can run the CDI importer. So I've already installed this CDI, using these instructions. So that part is already done. So now I'm going to create the Jammy VM using virtctl image upload. So let's do that. First, I need to create a data volume. So let me if you look over here, this is currently set to rpi.example.com, which is the node name. You can see that the node name is rpi.example.com. Now I will apply this. Okay, so the data volume is created. Now you can see that this example upload DB is ready for being uploaded. You can see there are two persistent volume claims and corresponding, there are two persistent volumes that are available. One of them is the scratch. So when we do the image upload, the scratch is going to allow you to upload the image to the persistent volume, okay, which is the persistent volume there. So let's run the image upload command now. We can also check the etc host file, and you can see the CDI upload proxy is present that is required to upload it. So this IP address with the CDI upload proxy -CDI, I've already added it to etc host, and now I'll upload this image, which I've already downloaded locally. So I have the Jammy server already present over here. I'm going to upload it. So when it finishes uploading, what I will do is I will create a VM that will use this particular image. I will edit this and make sure that when this image is going to be used, it will basically clone from this image that we are just uploading. So when it clones that, we have to make sure that the new persistent volume claim that gets created is going to use the current node name again. So once it finishes uploading, I will verify that. While it is still uploading, we can check whether the CentOS VM is started, and it is. So let's log in. And you can see that we are logged in. If I do cat/etc/os release, we can see that we indeed have CentOS stream 9, and I can ping outside the network, and that VM works. I can disconnect from it with control square bracket close, and that will exit from that VM. So uploading is now completed, and in the background, it is going to process that image and write it to from the scratch volume to the actual volume. So that is the task that is going on. So let's look at that. So this thing shows upload ready, but once it finishes uploading the image and processing it, you'll see that the scratch volume, which is there, the volume claim and the volume, they will get deleted. Both the scratch volume over here and this one, they will get deleted, and only this one will remain. And once that is available, what we'll do is we'll create a VM for Ubuntu. You can see the example upload DB where we just uploaded. That is the only one remaining. And you can see this Jammy server image was uploaded successfully. So now let's create this VM. Before creating the VM, I want to verify that the provision on node is set to our node name, and it is. So let's run this now. And you can see a clone has been scheduled. So what is happening in this process is that it's going to use this example upload DB, and it's going to clone into this Ubuntu Jammy 1. Okay, so there is this clone process that needs to complete, and for the clone to happen, it is going to start a pod. So if I do comma pods, so you can see the CDI upload Ubuntu Jammy 1 pod is started. And when this pod gets started, this actual clone starts over here. So the clone is now in progress. So this will take a couple of minutes to complete. And once the cloning is complete, then the VM will start. What we can do while this cloning is in progress is we can go to the console we can go to the console and look at it. So let's log into the console. You can see there is this virtualization that is already added over here, and we can look at virtual machines. You can see the VM CentOS is already running, and this one with the Ubuntu Jammy that is currently importing. We can have a look at this CentOS console from here also. Go to the console. It is currently upgrading, but we are logged in over here. We can run the top command. You can see the output. This is CentOS 9 stream over here also. Let's look back what is going on with Ubuntu Jammy. It is still provisioning. You can go to the console, and it is not yet started. So let's look at how far the cloning has been completed. The cloning is 10.45% completed, so we still need to wait for some time. While we are waiting for the cloning to complete, we might also be able to run one more sample. So let's go and run one of the object detection samples now. So we'll start that. So let's look at the object detection sample over here. What we'll first do is we'll install the Node-RED. This is required for the object detection sample. So I will leave this screen alone. I've already created this image, so I'm not going to create it again. I will just run these instructions and wait for Node-RED to start. Okay, so let it wait while Node-RED is starting. Okay, so this is where we can see that the VM Ubuntu Jammy 1 is currently running. Okay, so Ubuntu Jammy 1 is now started, and we are logged in. And if we do a cat/etc/os release, you can see that we have the Ubuntu installed, and we should be able to ping -c to google.com, and we can see that we get a response from Google. Cloud Init is still going on. It is going to do the updates, okay, and it will continue to do its work. But you can see, that we were able to connect to Ubuntu console also, and we have two virtual machines that are currently executing over here. Okay, these are the two VMs that are currently running. Now let's get back to the sample that we had started for Node-RED. Node-RED should be installed now. So let's connect to Node-RED. And we'll start. If you look at Node-RED over here and go to the dashboard, you can see the temperature, the humidity, and the pressure right now from the Sensehat, and we can change it from the default to another UI. It shows the temperature as a graph over here, and the same things over here. The barometer, hygrometer, and thermometer, you can see them. So this was the dashboards. What we are going to do now is run the object detection sample. So let's run that now. So I go to the object detection folder over here. I have already built this file and created the image. What I just need to do is check that the WebSocket and image upload URLs are correct. So it is showing the Node-RED SVC. That was the Node-RED route that we had created just now. And the host alias is my IP address. So everything looks good. So now I will apply it. You can see now that it is creating the object detection deployment. Once the object detection deployment is created, we should be able to start the chat, where it will show us the temperature and also show a picture when it detects a person. It will send a picture back to Node-RED. So we should be able to see my picture going to Node-RED and the current temperature in this room. If we want, we can see top, so that we can see how much memory is currently being utilized. We still have 2.5 gigs of memory available, so we are good. We have created 2 VMs and we are starting Node-RED, and now we are starting the object detection sample. So pretty good for the Raspberry Pi. So Python has started now, and we have the object detection running. So if we go to this thing, we can see that my picture is there. It can detect me, and anytime it detects me, basically it will send a picture over here. In addition to that, it should also be sending the temperature information right now. So if we look at the chat, you can see it's showing the temperature with the detecting of bounding box. I'm pretty sure if I hold a cup in front of here, it should show me the cup also. It should recognize the cup over here. Yeah, so it detected the cup over here now. If we go back to the Node-RED page, you can see you can find a cup over here. Thinks of it sometimes as a cell phone. Maybe if I turn it around, it will think of it as a cup. Yeah, good. So these were some of the demos that I wanted to show. So today we saw virtual machines being created either through Docker. We also saw virtual machines being created using the CDI. We saw the Node-RED that is showing the temperature and pressure and humidity information. And we also saw object detection sample running. So that is all I wanted to show for this demo. We have all of this running in MicroShift. Thanks for watching.